this is lesson 5.3, seasonal indices. Lesson objectives for lesson 5.3. What are seasonal indices and why do we deseasonalise data? This is to remove the effects of seasonality, so it's easier to see trends. So seasonal indices, we look at their average is equal to 1, how we can calculate them from raw data, and the interpretation, as well as how we can deseasonalise data, look at the formula, and how to correct for seasonality. So seasonal indices, a seasonal index is a number assigned to each particular value to each different season. So if you're just looking at 4 seasons, or you might look at months of a year typically. So you have summer, autumn, winter, spring. So each month would be assigned a number, a seasonal index. So for example, summer might be 1.1, autumn might be 0.8, winter might be 0.9, and spring might be 1.2. And so what these indices mean, it tells you how much above or below the average. So say we're looking at sales here. So how much above or below the average sales each season sales is. So summer sales. So because seasonal indices, the average is 1. Average equals 1. A seasonal index above 1 means that in that season sales are above average. Seasonal index below 1 means that in that season sales are below average. And so the higher or lower the seasonal index, the higher or lower above or below the average you are. So a seasonal index of 1.1 tells you that in summer you're going to be 10% higher than average. So in autumn, 0.8, so you're going to be 20% lower than average. So basically it just tells you how the sales differ from season to season. So because the season determines your sales because of other factors. So in summer your product might be more popular, summer and spring your product's more popular, so you tend to get higher sales in that time period. So seasonal indices denote in what periods have got higher or lower than average sales. And so just remember, we're looking at data here that does have seasonal variation. If there is seasonal variation, we can look at applying seasonal indices and deseasonalising. If there is not, then this is not applicable. So we'll look at how we can calculate them from raw data. So say we have our raw data, so our raw sales figures for our 4 months, summer, autumn, winter and spring. So summer we sold 100, autumn we sold 50, winter we sold 80, spring we sold 90. So the first step is to calculate the average sales for the year. So this is just over a period of 1 year, so year 1. So our average sales over the year, so calculating the average, we sum up all our data points, divide by the number of data points. So that will give us 100 plus 50 plus 80 plus 90 divided by 4 gives us a figure of 80. So now that we've got our average sales, we can calculate the seasonal index for each season. So the seasonal index for summer, that's going to be our summer sales divided by the average amount. So 100 divided by 80, and that gives us 1.25. And that tells us that in summer, sales are 25% more than average. You can do the same thing for the rest of your season. So autumn is going to be 50 divided by 80, 0.625. Seasonal index for winter is going to be 80 divided by 80, that'll be 1. So that tells us that in winter, the sales are at the average level, and then for spring, 90 divided by 80. And that will give us 1.125. If you take the average of those 4 seasonal indices, you will get 1. If you don't get 1, then you've made a mistake somewhere, because your seasonal indices over whatever time period it is have to average out to be 1. So if you've got four seasons, you add them all up, divide by 4, should give you 1. You might be asked to also calculate a seasonal index. You might be given 3 out of the 4, and so from that you can try and calculate the other seasonal index using the fact that you know they all have to add up. The average, has to be 1, so you can create an equation. So you have seasonal index 1 here, so your known value 1 plus 2 plus 3, and then your unknown seasonal index x divided by 4 equals 1. So these are all values you just put in, solve for x, you've got 1 unknown, put that on your calculator, use the solve function and solve for your unknown seasonal index. Interpretation, we went over that before, basically just saying that your seasonal index, so something like 1.25, means that you're 25% higher than average. Higher than average, something like 0.8 means that you're 20% lower. So 0.8, you take 1 minus 0.8, give you 20% lower. So it's just the difference between 1 and your figure, above or below. So higher, lower than average. Okay, so now we'll look at deseasonalising data. So this is where we really start applying the concept of seasonal indices. So the formula is pretty simple. You're deseasonalised, so I'll just write D for deseasonalised figure. That's going to be equal to your actual figure, so your actual sales amount, divided by the seasonal index. So if going back to our example there, a deseasonalised sales figure for summer will be 100 divided by its seasonal index, which is 1.25. So if we substitute that in, a sales figure of 100 divided by 1.25, we plug this into our calculator and we get 80. So whenever you've got a seasonal index greater than 1, when you convert into deseasonalised data, you'll end up getting a lower figure than actual, and that's to reflect that sales are slightly inflated in summer due to some reason, inflated more than the average. So by deseasonalising it, you're taking the seasonality out of it, and it sort of smooths your data, like smoothing. So if you've got just a plot here, so say your data went like this over your seasons, you apply your seasonal indices, get your deseasonalised data, and your data becomes more of like this, these blue dots. So your data becomes more like this. Sorry. Need to make sure we've on the small thickness here. Your data becomes more like that rather than this. Done it again. When will I learn? Alright, more. So you can see you've taken the seasonal effects out of the data, and you can better see the actual underlying trend. So those trends that are not related to the seasonality. So it helps to better see any increasing or decreasing trend over time. That's definitely what can be done by deseasonalising your data. So yeah, this is your formula here, and if you want to go backwards to get your actual value from your deseasonalised value, rearrange the formula. So actual value will be your deseasonalised value multiplied by the value of the seasonal index for that season. So we'll also just look at, I'll briefly touch on how we can calculate seasonal indices for data where we've got more than one time period of seasons. So maybe set the 4 seasons over 2 years. So what you do for that, so you've got year 1 and year 2, you've got your data here. You take your average for your year 1 and you work out your seasonal indices as normal. Do the same thing for year 2. So you have 2 sets of seasonal indices, one for year 1, one for year 2. So you've got summer, autumn, winter, spring, and then you take the average for each season. So your 2 summer seasonal indices, you take the average. Do the same thing for each season. I'll touch on that in the example question as well, but just explain that there now so you understand. And so our last little concept here, we'll be looking at correcting for seasonality. So these can be a tricky question. They do like asking a question like this. So it'll ask you by how much would you increase or decrease your actual sales figure to correct for seasonality. So this is looking at, so say we've got our deseasonalised sales figure. It's going to be our actual figure divided by a seasonal index. So let's say, for instance, we had a seasonal index of 1.2. So going from actual to deseasonalised, what you're doing is dividing by 1.2. But that's also the same thing. So if you do 1 divided by 1.2, you'll get 0.833. It's the same thing as 0.833 multiplied by your actual figure. So now you can see that, okay, your deseasonalised figure is now, 100 minus 83.3, or 1 minus that, if we're speaking in percentage terms here. So that'll give you 16.7. So you know that your deseasonalised figure is going to be 16.7% less than your actual figure. Or it's going to be 83.3% of your actual figure. So that's how much you need to increase or decrease. In this case, we're decreasing. You decrease your actual figure by 16.7% to get to your deseasonalised data. So they might ask that. So instead of thinking about it in terms of, okay, in this season, a seasonal index is 1.2, so this means our data is 20% more than average. We're looking at the difference between your deseasonalised and your actual figure. So for instance, let's pretend our actual figure was 100. So 100 divided by 1.2 gives you 83.3. So if you look at going from 100 to 83.3, if you decrease 100 by 16.7%, so 1% of 100 is 1, 16.7% of 100 is 16.7. 100 minus 16.7 gives you 83.3. So that shows you that you've decreased that figure by this percentage amount to get from your actual to your deseasonalised. Or they could ask it the other way around. In that case, you'd want to set it up. So basically, all you're trying to do is set up your equation here so that you can see you've got. So if they're asking for your increase or decrease, the actual to deseasonalised, you set it up in terms of deseasonalised to see that's your how much there. So if it's less than 1, you'll have to go 1 minus it to get your decreased amount. If it's greater than 1, so say it was 1.2, then you just look at the bit above 1, so the 2, the 20%. So that would be increased by 20%. So if you were looking going from deseasonalised to actual, you'd know that, okay, 1.2 times deseasonalised equals your actual data. So to remove the deseasonalised effect, you would increase your deseasonalised amount by 20%. So I've just rearranged this, the top equation there to this one, so you would increase it by 20% to get your actual figure. Just depending on which way they ask it. That's typically a tricky question, so if you can get that right, you'll be doing well. But you've just got to set it up in terms of, so your amount you change by, multiplied by your actual or deseasonalised figure in terms of the one you're looking at. So if they're telling you how much you increase or decrease deseasonalised figures by to get to actual, you'll have deseasonalised multiplied by something, and if it's the other way around, it's the other way around. Vice versa. Lastly, our example question here. Calculate the seasonal indices for this raw data. So we've got 3 years worth of data here. So year 1, 2 and 3. Summer, autumn, winter and spring. So we've got our sales figures for all these seasons. So I'll just fill these in quickly, and we'll go through the process of calculating our seasonal indices. Okay, so the first thing to do is calculate our average for each year. So our average for year 1, average for year 2, average for year 3. So we'll do that. We'll get our values. So our average for year 1 is going to be 1308.25. Average for year 2 is going to be 1436.5. Average for year 3, 1412.25. So just add up all your data points for that year. So year 1, year 2 and year 3. So they do this separately. Year 1, add them all up, divide by 4, repeat the process. We've got our averages now, so calculate our seasonal indices as we normally would, just for each year separately. So you divide each season's sales figure by your average, and so you'll end up with, so in year 1, let me just draw another little table up here. So this is year 1, 2 and 3, and it's in order from summer to autumn to winter to spring. These are our seasonal indices. So for summer, year 1, 0.83, summer year 2, 0.98, summer year 3, 0.93, and so on. So this is going to be our autumn figures over the 3 years, winter figures, and lastly spring figures. So from this we can see generally the sales are much higher than average in autumn, below average for the rest of the periods. And so then the last thing we need to do is calculate our average seasonal index for each season over the 3 years. So now we're looking at summer, autumn, winter and spring separately. So we just take the average of these. So for summer we take the average of these 3, average of these 3 for each of the rest of the seasons. And so if you do all these calculations, we'll end up with our seasonal indices. So for summer, the average of 0.83, 0.98, 0.93 will give you 0.91. Repeat the same process for the other seasons and you will get these answers. So autumn and winter and spring. So winter is 0.73 and spring is 0.34. So that's calculating seasonal indices. We have some raw data over multiple years. And that's the end of this lesson 5.3.